Hello, my name's Tom Wilson. I am the CEO of Emotion 3D based in Vienna, Austria. And I'm also the Technical Program Chair for the ICCE 2013. And with me is Simon Crosby.
Thanks very much, Tom. I'm the CTO and co-founder of Bromium, which is a company using virtualization on endpoint devices to improve system security.
So, Simon, it was a very interesting talk you gave just now, and as far as I understood it, there were two models of security, and one is the city of Troy, and of course the famous Trojan horse, which was led into the city with the strong walls, and you described that as being the model that we have today in terms of internet security and hardware security. Now, the other model was the Byzantine model, where a general gives information, the limited information that he needs to every one of his generals, and that it trickles down on a need-to-know basis.
Right.
First of all, have I got that correct? And could you say a bit more about that, please?
Sure. Thanks. Actually, that's spot on. It's perfect. So today's notion of security in enterprises and even on PCs is based on this really silly idea that you can detect the bad guy. And we've known since before the first computer system was built, it was mathematically proven that detection would fail. It's a very fundamental theorem due to Alan Turing, the father of computing. So this whole idea of being able to detect the bad guy and keep him at bay by big perimeter defenses like the walls of Troy is known to fail. And it fails regularly, and we keep on punching new holes through the perimeter and so on to let new applications through. And so what we know about organizations where you have these big walls around them, very similar to the city of Troy, is that you can't be productive. So the problem is that IT gets to be the barrier between an employee and productivity. And whenever that happens, the employee is going to go and do it anyway. Right? They're going to go, this we call a shadow IT. The employee will drag your files to Dropbox and work on them on their own device or something. And therein lies a security issue as well. So the Trojan problem is basically it asserts that you can detect the bad guy. When the Greeks left a horse behind, nobody was expecting that, and so of course they managed to get into the city, and that was the first Trojan horse. The notion that you can detect the bad guy when the bad guy is continually changing shape is basically fatally flawed, and people need to move on. We need to move on. And then the other approach is then one of Byzantine security, which basically says that if you can build a system which, even when it is attacked and compromised, will nonetheless protect the system. That is essentially known as a Byzantine fault-tolerant system, and I outlined the way that we're doing this at Bromium, which is through the use of a tiny hypervisor added to any system, which gives us an opportunity to enforce least privilege. And people would know about least privilege. We use it every day in our lives. We will have all heard about doctor-patient privilege or client-attorney privilege. And then all that says is that the information that's disclosed in a particular context, here think of an application like a tab of your browser facing Facebook or something, the information that is used there is only that which is specifically needed to correctly execute, and nothing else is visible. And no networks are visible other than specifically the network that's required for that. So if you build a system based on this principle of least privilege, adopting this mechanism which has been known forever as the way that humans structure their lives, you can build something which is inherently resilient by design, and even when you are attacked and cannot identify the attacker, you can build a system that will survive the attack.
Would this in any way be analogous to a system composed of multiple virtual machines, where information isn't shared between them?
Logically, yes. That is, in general, what we know from virtualization is that the hardware capabilities that have been added to CPU to allow virtualization also necessarily enforce security segregation, because you don't want your VM chit-chatting to the VM next door. And so the hardware vendors have done the right thing there. But we're not talking about virtual machines here, because virtual machines each have their own operating system and one or more applications running them, and that's not a useful abstraction for building a consumer device. What consumers want is great devices that are resilient and that support multiple different applications. By the way, they want devices that they can use both for work and for play. And so the challenge there comes in that there is this explicit boundary between the enterprise and its intellectual property rights and its requirements for compliance and what I do as a consumer. And so the device must inherently have these properties which guarantee that it will build a bastion of trust, both for me and for the enterprise, and defend it at all costs. And that is fundamentally going to be a hardware principle.
Very interesting. So, to what extent does the consumer need to change his or her behavior, and to what extent does this need to be built in by consumer electronics manufacturers?
Yeah, so this idea that we need to change our behaviors to use devices is just broken. We need to get rid of that. I mean, we're humans, right? And if devices can't model how we are as humans, then it's a bad device. And so we've seen lots of mistakes like this in the past from operating system vendors. You know, the UAC in Windows for Windows Vista just confused the heck out of users. We have an intuitive ability as humans to deal with this notion of least privilege or relative trust, and we sometimes make mistakes. And so the system has to have these two properties. One is that it must give us the intuitive, obvious user experience, must not be in the way, I must just, I use stuff and stuff works. But also, when I make a mistake, it must save me. And its boundaries must be incredibly hard, hardware hard. That is, when the software is totally compromised, as it inevitably will be, the attacker would have to break the hardware of the system in order to compromise it and get hold of the data or whatever is on it. And so those are the two key requirements which we can deliver.
So what would happen if we don't change our habits, if IT within large organizations isn't modified, if we carry on the way we are, and if consumers continue typing in their credit card details to websites that are untrusted? What happens if we carry on in that way, and what is the rosy alternative?
Well, it's reasonable to question whether we aren't at a point of massive societal risk. And I'm not trying to be a doomsday guy here, simply because of the fact that our systems are so bad at securing themselves, and we are so hungry for these new online experiences. We're consuming these applications which are free and for which we hand over all of our information. And so what we can tell is that any information that you have contributed anywhere, somebody else could have got hold of, right? It's very simple to do this in general. And so that's a very scary concept for society in general. Indeed, we have never been so vulnerable in the sense that all of our assets are somewhere online now, on a computer someplace, and that computer is absolutely vulnerable to attack. So nuclear power stations, water supplies, fuel supplies, these logistical systems which run entire countries are massively vulnerable to attack. And this has been shown in malware attacks over the last few years. So it's looking pretty bad. Here's one thing. I think it's important to say what you can say with absolute certainty. The current approach of delivering large software systems, which are inevitably going to be vulnerable because they were written by fallible humans, and be used by humans who are gullible and will click on the wrong thing, is just got to end, right? That is, we can no longer proceed on the basis that these large monolithic software systems will be good enough for security. We've been showing now for the last 2 decades that they aren't, and that the next patch is not going to save you from the 0 day after that. So we have to get out of that, and what I posited here is that security has got to be an innate property of every device. And it's simple to implement. The tools needed to do this, I used virtualization as an example, but basically a small isolation kernel which can enforce least privilege, 100,000 lines of code, it's all open source. These are available, and vendors should go and do it.
What is it going to take for vendors to take this seriously? We've already seen, as you mentioned, attacks on infrastructure so far in the last few years. Is it going to take some kind of IT Armageddon for people to take this seriously and understand that they need to fundamentally rework things? At the moment, there hasn't been anything where people think, I've got to change.
I think one has to distinguish between consumer and the enterprise. In the enterprise, where people are required to comply by law, if there is a better technology, then they definitely need to look at it, and that's fine. We can go down that path. The other thing we can rely on is that, to the extent that an entire organization will fail if the bad guy succeeds, stealing their intellectual property, say, then people in those contexts appear to be going down the right path. However, they're also stuck with the legacy notion that the walls of Troy still have to be in place and everything else. In the consumer context, I think it's really tricky because we cannot rely on users, just consumers of a device, to make rational decisions about security. You don't know whether the attachment is good or bad. You don't know whether the URL is what it looks like or something else, right? Or a tweet trunk URL in Twitter, which could point to some malware. And so we cannot expect users to make rational decisions. So the fundamental challenge then is on a device is to build a device that's going to protect the user no matter what. Even when the user makes a mistake, we have to be protecting the device even if it hasn't been patched, and we have to just throw away all malware.
Simon, thank you so much for a very interesting keynote and for taking the time to talk with us afterwards. Thank you very much.